Hello, my name is METİN Arıbaşır. This is 13th part of my explanation of my theory. This video is continued part of rhythms in spectra, the blackbodies, musical instruments of subjective reality, best and unique players of all bodies in universe, free electron motion forms. Where we will put the atom-tight single wave pulse line, spectral line, absorption line, or emission line on the continuous spectrum, which belongs to relocating free electron motion form. What is correlation between two light types? Single wave pulse from atom-tight electron motion form and successive waves from free electron motion form, and relocating free electron motion form successive waves were variable respect to relocating velocity of free electron motion form and respect to its direction, etc. According to my theory, my drawings yes. Firstly, for single wave pulse for X-rays, I will explain on these graphs according to my theory and my formulas. Wavelength, intensity or energy. Wavelength, intensity or energy, intensity, energy. Okay. We will compare the systems. Firstly, from free electron motion form successive waves, continuous spectrum, X-rays. Here. But for X-rays, we know we apply the system voltage, electric potential. Okay. We say electric potential for first graph, voltage 1. For second one, voltage 2. For third one, voltage 3. Okay? Now, voltage 1 smaller than voltage 2, applied voltage 2, smaller than voltage 3. Then, starting point here. For voltage 1. This is continuous spectrum according to my theory and my formulas. this shape from relocating free electron motion form. At a certain velocity, it is relocating. Okay. But here, this is the direction. This is electron motion form. (90°). Here, 90°. 90°. 90°. Then here 0°. 0°. 0° represents 0°. This is electron motion form. Okay. This electron motion form at V1 velocity, left side here. Here, D equal C minus V1 and lambda n minus delta lambda 1. Okay, here. This point. This point, 90° point, starting point. Okay. This is the normal. This is the normal wavelength. Lambda n. Here. Here. Lambda, this point. Lambda n. Lambda n. This point, according to my theory, lambda n minus delta lambda cosine alpha. But in this direction, 0° equal 1 because of lambda n minus delta lambda cosine alpha. If 0, this is equal 1. Because of it is equal 1, result lambda n minus delta lambda. Okay. Here, shorter wavelength and shortest wavelength. Here, 180° lambda plus delta lambda. Okay. Yes. Where we will put the atom-tight single wave pulse line on the continuous spectrum. Say, this point 0.0709 nanometer. Key alpha from molybdenum. According to me, this key alpha is from atom-tight electron of molybdenum by effects of free electron motion forms successive waves, enlarging, say, absorption. When vanish this effect of successive waves, shrink again, then key alpha pulse emission. This is emission. Okay. This is continuous spectrum. This is emission line. They say these type points, for these type points, they say characteristic rays. But no explanation. What is characteristic rays? And they say for this graph, I don't tell you now Bremsstrahlung. Bremsstrahlung. In German language, Bremsstrahlung. Different frequencies together constitute, they say. Accepted physics theory says that, but this is not explanation, and I will not tell now. Then I will tell you. I am telling now according to my theory and according to my formulas, and I draw that according to my theory and according to my formulas. Okay. This pulse 0.0709 nanometer. Here, say this lambda n is equal 0.6 nanometer. Say this point I have put for a formula for this, but I will not say now, but I will. Okay. This point (0.409 nanometer). Say, between this scale, this is the wave pulse of molybdenum. Say key alpha. Okay. Don't forget. Wavelength. For all of these three graphs, same point. This is 0.0709 nanometer, same. Okay. When molybdenum atom type, atom bounding electron, tied electron, enlarged by effect of free electron motion form at certain quantity, then when these successive wave effects vanish, first the one-day effect, enlarged at the rate of n square. Okay. Then, when the successive waves of free electron motion forms vanish, enlarging, according to me, absorption, then go back its initial wavelength or another position, another wavelength step. Okay. A certain pulse, single wave pulse. Here. Enlarge, shrink, while shrinking, pulse. Single wave pulse. Key alpha, say, if this pulse has an energy quantity and corresponds this a kind of wavelength, okay, not successive wavelength, representative wavelength, this key alpha, 0.0709 nanometer. When this wavelength coincides with these free electron motion forms, which is relocating, it's variable. If it finds to coinciding point on this graph, same wavelength, yes, superposition, then line, emission line is displaying. Okay. Here, this is applied voltage. Now applied voltage, greater voltage, say this is relocating electron motion, or represent this graph, like black body radiation graph. Voltage high, velocity of electron high at the same rate. Here, greater voltage, greater velocity, and narrower in the direction of relocation, narrower wavelength. Okay, then this graphs. Look at that. Alpha 1, location of single wave pulse, and here same 0 point key alpha from molybdenum, atom type, from atom type electron, single pulse here. Okay, look at that. Alpha 2. Okay, here this the smaller wave velocity, this at this point, and lambda n minus delta lambda 2, smaller wavelength in the direction of 0 degree, okay, and higher energy. But compare these two graphs, angles changed, position same. Okay, coincide. Then, if greater applied voltage, greater electron motion velocity, more narrower, lambda n minus delta lambda in the direction of 0 degree. Okay, here. Greater alpha 3. This point key alpha 0.0. Okay, this is Now, according to my theory, this is my drawings according to my theory and my formulas. At that point, okay, this is at angle. At that point, we can find and we can think of three-dimensional and in continuity. Okay, like this. Now, here, at this point, say D two, wave velocity and wavelength and energy. At this point, 90 degree, you know lambda, and D equal C. Okay. We can find this. Don't forget, these curves graphs, black body radiation graphs, same shape. But these shapes belongs to relocating free electron motion forms, variable waves, variable wavelength waves graphs, and variable light velocities, variable point energies in each point in spherical, and if we think successive waves, first, second, third, change. Okay. But what quantum theories say? This curve has quanta. No, this is continuous spectrum. They didn't understand. Single wave pulse like this, key alpha, key beta. Okay. From atom-tight electron motion forms by effects of best players, free electron motion forms and their successive waves. Play this guitar or piano. Okay. Only these lines, emission lines like this. If enlarging like darkness while shrinking, single wave pulse propagating emission lines, okay, or absorption lines, same, like white, black photographs. Quantum built on these lines and generalized its theory on this foundation, but foundation is wrong. They try to explain black body radiation on this continuous graph, but no. And in discontinuity, they try to explain wrong. Like this, from the sun, or from the stars, like these graphs. Same foundation, continuous spectrum. Relocating free electron motion forms successive waves. This is the source. Okay? Here, applied voltage. There, for sun, for another galaxies, stars. Temperature. Gain the free electron motion forms, make it gain velocity. Free electron motion forms. It's not important whether you apply voltage for X-rays, production, or apply temperature for heating systems. Say, sun has temperature and free electron motion forms in motion, relocating, then they make this. Now we looked at one, two, three. Temperature 1, temperature 2, temperature 3. Velocity of electron relocating, velocity 1, 2, 3. Temperature 1 smaller than temperature 2, smaller than temperature 3. Okay, temperature high, electron velocity high at the rate of same. We understand that. Now, intensity, wavelength. Here, high temperature from the sun. Higher temperature, greater relocating electron motion form velocity graph. Then, say heights, not heights, but okay, here. Greatest electron velocity, say. Visible light, this band, okay? Like X-rays, remember, here, lambda n, according to my theory and formulas, 0 degree, 90 degree, 0 degree, 0 degree, 90 degree, 90 degree. Yes, this point we say, this band, okay. Delta lambda 1, delta lambda 2. Delta lambda 1 smaller than delta lambda 2, smaller than delta lambda 3. Here, electron lambda n minus delta lambda 1. Delta lambda greater, lambda n minus delta lambda smaller, this wavelength, smaller wavelength, in the direction of relocating. Okay? Lambda n minus delta lambda 1 lambda n minus delta lambda 2 smaller than this smaller than this. Remember, this is the alpha 1, alpha 2, alpha 3. Alpha 1 smaller than alpha 2 smaller than alpha 3. Okay. This point, same point. Whether X-ray spectrum or from sunlight spectrum, blackbody spectrum, they say. It's not important. Light, this shape, according to my theory, is proof that light velocity, the light and source, is not isotropic. The light is anisotropic, depending on its direction.